Okay, so next we look at the example. Okay, we have example 9 here. Find the unit normal vector, okay, capital N, for the vector value function provided. So, remember, in order for you to get the unit normal, you must compute the R prime, and then you need to evaluate its magnitude, and after that you have to compute the unit tangent, and then after that you have to differentiate the unit tangent, and after that obtain the magnitude of unit tangent, then you can have the unit normal. So it is a bit long process. So if you did wrong here from the R prime, so meaning that all your answers here are affected. So be careful while you do the calculation. Okay, so now what is the information that we have from the example? So they give you the vector function R. Okay, so then you have to differentiate. And then when you differentiate, you got 1 to t. And then you need to obtain its magnitude. Okay, remember they give you the specific t, yeah? So meaning that after you compute for each vector, you have to substitute the t equal to 1. Okay, so if the question is not asking you to sketch the curve and sketch the unit tangent and sketch the unit normal, so I don't think the given t is important. Okay, because if they just give you the t but then they don't ask to sketch, so it's just nothing. So in the complete version question, it's just like this. So they will give you a function, they ask you to compute the unit normal, unit tangent for the specific t, and then you have to sketch them. Okay, so then there is a reason why they give you to compute for the t and n on the specific t. So then we can make use from that. If they don't ask you to sketch, so just nothing. Okay, just calculation. Okay, so magnitude of the R prime. So 1 plus 4t squared. So I hope that you know the formula of the magnitude of vector function. So you have to square each component and then you have to sum them up. And don't forget to provide the square root. It's just like you compute the length of 2 points. So same idea. Okay, so now maybe because they give you the specific t, so we compute the vectors for the specific t. So the vector r become 1, 1, and the vector of r prime is given by 1, 2. So the magnitude is square root 5. Okay, so now we can, before we can have the unit normal, you must obtain the unit tangent. So the formula is r prime divided by its magnitude. So in order to compute this, you can directly use this. So you have already compute that. So you have 1, 2 divided by square root 5. Then it will give you for each component 1 over square root 5. Y component you have 2 over square root 5. Okay, but that is your t. But since you already substitute the t, then how can you evaluate the unit normal? So meaning that you can directly use the value that you obtain just to compute the t. But in order for you to get the n, you have to differentiate. So meaning that you have to use the expression in terms of t. Okay, in order for you for you to obtain the n. So instead of we use this, so this is also useful because after this you have to sketch them. So this is the thing that you are needed as well. But then because we are computing the n, so you have to work in terms of t, in the in the expression of t. So your t is, so r prime, so this is your r prime in terms of t divided by, so the magnitude is in terms of t 1 plus 40 square. Okay, so next we are computing the n, which means that you have to differentiate. You have to obtain the derivatives of the unit tangent. And you can see that it is not so easy because when you expand this component by component, you have 1 over square root of 1 plus 40 square. That is for component x. So then for component y, 2t over square root of 1 plus 40 squared. Then in order for you to differentiate the t here with respect to small t, you have to, you have to put the d over dt for the whole vector function. So then it's not so direct. So you have to implement the chain rule. Okay. So first here we compute the derivatives of, so this one I rewrite into 1 plus 4t square minus 1 over 2. And then when we differentiate, so we have negative 1 over 2, 1 plus 4t square, negative 3 over 2. And then chain rule, so we have 8t. Then we can simplify. We have negative 40, 1 plus 40 square, negative 3 over 2. Okay, so next, the second component, we have 2t over square root of 1 plus 40 square. Here you have to apply quotient rule plus chain rule. So here we consider, let's say u here is 2t, and then v is 1 plus 4t square to the power of 1 over 2. So ut is 2, vt is 1 over 2. Yeah, we apply the quotient. Okay, 1 over 2, so 1 plus 4t square, negative 1 over 2. Okay, and then chain rule, so we have 8t. When we simplify, we have 40 over 1 plus 4t square, 1 over 2. Okay, so now so for this one, so u v u t u minus u v t over v squared. And we substitute the info that we have here, then we will get, okay, so that's what we obtain. Okay, so this is derivative for the second component, and then that is a t prime, and then we compute the magnitude. So the t prime here is quite long, so the t prime is the, so we substitute the result of the first component, So minus 40, 1 plus 40 square, negative 3 over 2. Then for the second one, 2, 1 plus 40 square minus half minus 80 square, 1 plus 40 square, negative 3 over 2. Okay, so that is the not the t but the t prime. T prime vector. Okay, now we want to find out its magnitude. So you have to square all the component here. So this is not direct technique, especially for this one. This one okay because you have a single term here, but this one you have to term, then you have to square them. It's a bit long process. Okay, so when you square this one, so this become 16t square, and this one the over 2 gone, and then plus the square of this component. Okay, so now I focus on this, then I obtain that we have that thing. Okay, so I'm using the formula of a plus b squared. So we have a square plus b square plus 2ab. Okay, so not just a squared plus b squared. So this is wrong. Okay, now okay, so after I put this back into the previous I put this blue back into the magnitude of t prime. So now I rewrite into a fraction form instead of power of negative here, and then here it looks like we have to simplify the form. What we can see here, we have a cube, then square, and this one just power of 1. So we can expand this by multiply this square, and this one just multiply by the 1 plus 40 squared. And then we expand this, and when you expand that, and we obtain this one, so this is square, so this is the result, and then expand, and then hopefully we can simplify. Okay, so out of battery. A few terms can be cancelled out, so we only have 16t square plus 4 over 1 plus 40 square cube. Now we can obtain the unit normal vector, which is t prime over its magnitude. So from our previous result, t prime is this one. So we have to divide this component by the magnitude of the t prime, and similarly this one as well. Okay, so we need to rewrite that. This is a bit long expression. So we have, so the first one just now we have minus 40 over, so that is for the component of the t prime, and we have 1 plus 40 square 3 over 2 divided by, so we divided by here so divided by this one, okay, divided by the magnitude is given by, but since it is divided, so I just make it upside down. Okay, so here I have the square root of 1 plus 4t square cube divided by 16t square plus 4. Okay, and then that is for x component, and then for y component, so it is a bit longer. So that is the second component I put down here. Okay, not enough space, so we have bracket 2 over 1 plus 4t square 1 over 2 minus 8t square over 1 plus 4t square 3 over 2 multiplied by the divided by the magnitude of t prime. So just make it upside down. So we have 1 plus 4t square cube divided by 16t square plus 4. So that is our n. It's not so easy, but it is a reality. Okay, so now because we have if you realize here we have the similar term, so this one actually can be divided into 1 plus 4t squared 3 over 2, and we have the same thing. It looks like we can simplify the form. So now the next, please try to simplify this form, and here maybe we can also do the same. Okay, in order to simplify, I'm just take term by term. So the first component, it looks like we can simplify, and after that we can have a more simpler version, so which is this one. So this one can be rewritten into this form. So next, we want to try to simplify this expression. So maybe we need to expand this term and then expand this term as well, and then we simplify. Okay, so this one multiplied by this term, and this one become 3 over 2, and this one can be factorized, and we have this one. Okay, and then minus this component multiplied by this expression, so 8t squared multiplied by 1 plus 4t squared 3 over 2 divided by this one multiplied by this one, also can be factorized to be this form. So you can see that this one can be cancelled out, and this one become 4, and what else, this one gone. So what we can have here, so this one can be simplified. We have 3 over 2 minus 1 over 2 will give you 2 over 2, and it's become 1. So we have just 1 plus 4t square minus 4t square over square root of 1 plus 4t square. Okay, so now this component has been simplified into this form, and this component, after we expand and then simplify, we can have this form. Okay, so we can say that now our n is minus 2t over square root of 1 plus 4t squared in square root of 1 plus 4t squared minus 4t squared over the square root of 1 plus 4t squared. And since here we have the same. It looks like again we can simplify. Okay, we try to simplify for the second component. Negative 2t square of 1 plus 4t square, and this one, and we have the same denominator, so we have 1 plus 4t squared minus 4t squared over square root of 1 plus 4t squared, and this one cancel out, and we can see that now our NT unit normal vector is become minus 2t 1 divided by the square root of 1 plus 4t squared. Okay. So that is it, but still unfinished because they ask you to evaluate. Okay, just now we have done to compute the t. Okay, so now we want to get the t, the unit tangent at t equal to 1. So you have to find out where is your t just now. So where is your t? This one. So that is your t. And then you have to substitute t equal to 1 in that unit tangent vector. So where is your t? This one, I think. It's this one, t. Okay, so this is t in terms of t. So now the t at 1, we obtain that. Actually, we have already computed that from the beginning just now. This one. So that is your unit tangent vector at t equal to 1. At t equal to 1. Now we want to compute the unit normal vector. So we have done this. So now we want to compute this. So the unit normal vector at t equal to 1 is minus 2, 1, square root 5. Okay, or you can have minus 2 over 5, 1 over 5. So what we have so far, because you have to sketch. What is the thing that they ask you to sketch? Sketch the curve. Okay, you have to sketch the curve here. The unit tangent. And unit normal. Okay, so it looks like the question is just asking for sketching the curve. Okay. So okay, now we just sketch the curve. So by sketching the curve, okay, we look at again the information that we have here. Remember, I told you before how to sketch the graph. In this case, you can have the parametric equation where your x is equal to t and then your y component is t squared. So now you have a parametric equation. So how can you convert from parametric equation into Cartesian, which is just x and y? I have mentioned that one before. So in this case, what you can do is just use a substitution. Because it's said to be t is equal to x, meaning that from there you can have y equal to x squared. So now you have a quadratic. So since we have only I and j, you have to sketch onto the system. So your graph is a quadratic graph. on y-x plane. Okay, but normally in exam, they will ask you to, after sketch the curve, you have to label and plot. Yeah, normally they will say that sketch the unit tangent and sketch the unit normal vector at t equal to 1, meaning that you have to show it on the graph. So that is the thing that I want to show it to you, because the complete question is they will give you the vector function and they will ask you to sketch the graph and they ask you to compute the unit normal, unit tangent. And from there you can see that the n and t, they are always perpendicular. So that is the complete set of question in a exam. Normally it's to be like that. Okay, now I will teach you how to sketch the unit tangent and unit normal, but on the next video.